All right. It's on there. Let me put this up on the board. We're going to start off with section 20 or 10.6, right triangle geometry or trigonometry. That's really all I'm worried about kind of for the rest of this chapter. We're going to do just right triangle stuff. I'm not going to worry too much on, God bless you, on the like other types of triangles. So for the most part, if you're dealing with triangles and you need to get some numbers for you, we'll just stick with the right triangle stuff. And then does anybody want a note card? That way they can use this whole entire lesson is going to deal with just SOHCAHTOA stuff, just the trigonometry stuff. So if you want to write this on a note card, just that way you don't have to flip back and forth in your notes. And again, this is just kind of a free one for if you need test quiz and stuff. So you can have multiple note cards as long as you do this one.
I'm way better. He's terrible. He gave up like 100 points in the street. That's right. Everybody else got to
Okay, so I'm sorry that you guys were done. Okay, I'll wait for a second.
I'm confused. Why is opposite? Why do you have the opposite adjacent color?
So I'm going to talk that one, but it depends on which angle you're looking at. So I'm going to talk all three of them as soon as that picture is there. All right, so you asked the question, so I'll kind of stick with it. For this triangle here, okay, so we've got the right triangle. This corner is going to be the 90-degree angle. This will always be the hypotenuse. The ones directly across from the right angle, that was always going to be the hypotenuse. However, I'm looking at angle B, the one that I highlighted in blue. This one is going to be the opposite side of that angle, and this one's going to be the adjacent side for that angle. So opposite, adjacent, this will always be the hypotenuse. For angle A, which is the yellow one, that's going to be the opposite, this one will be the adjacent. So when you are looking at it, trying to work through it, again, sine, when you have sine, it's going to be the opposite over the hypotenuse. Cosine of the angle is going to be the adjacent over the hypotenuse. Tangent of the angle is going to be the opposite over the adjacent. Some little things I want to point out and make sure that you guys kind of identify and you write down is that this letter that's right after the sine, cosine, and tangent, that is always going to be the angle. So it'll always be the degree itself. So I mean, kind of a little point to it. Hopefully it'll let you know what I mean. But every single time you see this one, that will be the degree. All right, we'll go through. We'll start solving a couple of these ones that I'm going to have you guys practice with. But you guys will be using your calculators to actually do the sine, cosine, tangent, and then the inverse of sine, the inverse of cosine, inverse of tangent, just so we can get some practice.
What is the point in finding sine?
So that way you know what the actual angle is.
Just get a protractor.
So there's times you can't use a protractor.
Like when it's huge.
Yeah. So like, and again, it's rare that normally people are going to probably have a lot of these examples, but oddly enough, I actually have a couple of these examples. So like this one, I was in Afghanistan in 2010. We were having to build new bee huts, like big old buildings or wooden buildings.
2010, I was just going to first grade.
So anyway, 2010. Up until that point, we're living in tents, and they're shooting like rockets and whatnot towards us. Mortars, not great. Tents don't tend to stop those things very well. So we're gonna build stuff out of 2x4, like actually hard buildings. However, to build those, we had to figure out how to make the rafters. We wanted to make the rafters somewhat structurally sound, so we could make a jig on the ground, so we can build a whole bunch of them all at once. So this was actually one of the things that I did was I actually went through and did the math to figure out what the angles needed to be to make the rafters, so that way we could live inside actual buildings instead of inside tents. So not normal that you guys are probably going to be building stuff with these, but again, we didn't have a protractor, like a little compass to really work with, so we were able to kind of go with that.
You use sine, cosine, tangent.
I did. All right.
You got to show your work on that. I'm sorry.
I'll tell you what. I'll show you the what I made. We had a building set. We had a projector inside, so we could actually watch a TV show.
We need to run those.
So here's my building here. The roof that I made, we wanted to have a vaulted ceiling. Look like that. So that way we could have our little projector up here. So I had to figure out what this angle had to be. And then again, I just kind of broke it off and made some right angles that way. We had that. So that way I could put together my whole entire triangle to make my rafters for a vaulted ceiling.
Why wouldn't you just make a flat ceiling?
Because we couldn't, because otherwise we wouldn't be able to like put that little projector to actually watch movies.
Flat ceiling.
It was this tall. It was a 9-foot ceiling. But if we did that, there's no way to actually see at the other end of the room. Otherwise, you got a screen maybe this big for, we have like 70 guys.
Put it on a cart in the middle. You know?
Then everybody walks in front. You got that. Anyway, so that's my sine cosine rules. All right. So anyway. All right, so looking at these ones, I'm going to go through some sample problems. Okay, when I give you these ones, or when we give the stuff in the book as well, you'll have a chance to go through and do the sine of one angle, cosine of another angle, tangent of another angle. If they give you all three sides of the triangle, then you can go through and you can do the sine, cosine, tangent. So, this angle over here, angle C, this one's going to be my right angle. So for this part, I will write those ones down so you can kind of get an idea. Let me get my handy dandy other color pen. But my triangle, I've got AC is 6, BC is 8, and then AB is 10. All right, so sine is going to be opposite over the hypotenuse. So when I write this one, sine of A, so this is the angle I'm looking for. The opposite will be 8, will be one across the way. And then hypotenuse will always be this one. So for sine of A, I've got 8 over 10. Actually, I'll stick with my A here. So this is always going to be my opposite. For A, this will always be my adjacent. For my cosine of A is going to be the adjacent over the hypotenuse. So my adjacent number is going to be 6. Hypotenuse is always going to be that 10. And then my tangent of A is going to be my opposite over the adjacent. So I'm going to have 8 over 6. Okay, we're going to solve this 3 separate ways. I'm going to put on the lights, that way you can use your calculators as needed. But for us to figure this out, let me kind of make... If you have a calculator, if not, I have one that'll work up here. Okay, so for sine of A, the way this is going to work, it's telling us, if I did 8 divided by 10, and I'll write it out, sine of 8 divided by 10.
Which one? The opposite can be different.
Correct, so it's based on whatever angle you're looking at. This was always talking about angle A, so it's saying all of these for angle A. So from this angle here, the one on the other side of the triangle will always be the opposite. So if I were to start going through the steps and I had sine of A, so I'd have sine of A equals, and I did 8 divided by 10, it gives me that 0.013, I'll say 14. If I want to know the actual angle of this, because I don't know the angle, in order for me to get this A on a side all by itself, I'm showing you the long way to do it. You won't, if you can't remember it, you don't have to do the long way. I'm trying to get A on a side by itself. So I'd want to divide both sides by sine, which is tough because we really don't know what it is. So on your calculator, for you to be able to solve for whatever this angle is, hopefully you can see where your calculator says sine. You guys have a calculator? So there is, I took 8 divided by 10. I did that wrong, I probably did. Oh, sorry, I completely did one backwards, sorry. Yeah, you're right, I completely screwed that up. I got your, yeah. So I got 0.8. I screwed that one up too. It's not even the right one. So I have 0.8. For me to figure out what the actual angle is, on your calculator, you're going to hit that sine to the -1, so the inverse of sine. Because we have to divide by sine. So when you divide by something, it's the inverse. So on your calculator, you're going to put the inverse of sine, so sine to the -1 power. And then you either put 8 over 10, or you can put 0.8. What'd you get for your angle?
4.58.
Should have been 53. You put 0.08. Instead of just 0.8, okay. So, excuse me. So if I solve for this one, this top one, I'm not going to make us do every single step, but I got 53 0.1. All of these, because it's still the exact same angle, should give me the exact same degree. So I want you to go through, and in your calculator, I want you to do the inverse of cosine to 6 over 10. They should all be the same. So I should get 53.1. If I do the inverse of tangent over 8 over 6, I should get the exact same answer again. What am I like? So what I'm doing right now is I'm showing you, if you have all the sides, you can punch these into your calculator and figure out what the actual degree is going to be.
Okay, so that thing that's next to 6 over 10 is like you doing that cosine minus 1 thing.
Yep, that's the inverse of cosine.
Where says
Raylo,
Yes, ma'am.
are you doing hers? You do that side thing.
cosine?
Yeah, okay. I probably should have started with this one. On your calculator, right now for everybody, I want you to put in sine of, let's say, 60 degrees. So sine of 60, and then hit equal. You should have 0.866. You don't. I'm guessing you are in radians. You are in radians. So I went to mode.
Whoa.
And we were actually
This
degrees.
kid is bad. These and you just hear the air.
There you go. Did anybody else have something besides 0.66 or 0.866? Okay. If you had something different, you might be in radians, and I'll fix that one. Okay, so anyway, if they give you the sides, I'm going to write this little note down for you. If they give you the sides and you do not get an angle, you have to use the inverse function. Okay? So if you get the sides,
Do me.
okay? So if they give you the sides but not an angle, you need to use the inverse function. So on your calculator, it's like where it has to the second power. So it'll be like, I'll write it here, like sine to the -1. This -1 is what shows that it's the inverse power. All right, so going back to my very first triangle here, let me grab a different color pen. When we punched all this stuff in, depending which one you did, and again, you don't have to punch it into your calculator each time. I'm mainly just understanding on how you set it up correctly. We found out that this angle is 53.1 degrees. Can we figure out the other angle without having to do sine, cosine, tangent again? What are you going to do?
Add the 90 and the 53 and then subtract it from 180.
Yeah, every single triangle is going to be 180. So we just get to subtract these angles from 180 to figure out what the other side is going to be. Okay, so for that last angle, if we needed to find it, it would be, 36.9 degrees. So again, if you find one angle, you can figure out the other ones just by subtracting from 180. You don't have to do sine, cosine, tangent to figure out the other side. So once you find one angle and a right angle, or right triangle, you can get all three angles. If you get two sides of a triangle, can you figure out the third side? Do you remember how to do that? Yeah, that guy. Okay, should have it written down. But again, if you get two sides, you can use this to figure out the third. If you have all the sides, or if you have two sides of a triangle and you need to find angles, you're going to use that sine, cosine, or tangent. Okay, so back over to this one. We're going to get down to this other story problem-ish one, which you'll see kind of on the second half of the assignment today. It says it's going to give us kind of a story problem. If in doubt, draw a picture. Doesn't have to be a great triangle. Just draw a little triangle so that way you have something to work with. It says find side A if angle B is 72 degrees and side C is 300 centimeters. And they want us to find this side. Okay, so they're giving us this angle right here. So from this angle, what is the name of this side over here? Is it opposite, adjacent, or hypotenuse? Yeah, this one down here is going to be adjacent. So they give me the adjacent. This 300, what's another name for that one? Hypotenuse. So looking on your note cards, looking on the board up here if you need to, which one uses adjacent and hypotenuse? Perfect. Cosine uses, so it's going to be cosine of the angle equals adjacent over the hypotenuse. So to solve it, I'm going to write it exactly with every piece of information that I have. It does give me the angle. So I've got cosine of 72 equals my adjacent, which I don't know, so I'm going to give that an A, over my hypotenuse, which is 300. All right, the nice part is that if you do get an angle, you can punch that directly into a calculator and you can use it to solve it, and it'll give you a decimal. So for me to figure out what side A is going to be, I need to get that part on the side of the equation all by itself. Again, I'm turning it on so that you guys can use your calculators. So for me to get this A on a side by itself, I'm going to multiply both sides by 300. That means this one and this one will cancel out. And to figure out the angle, I'm going to type in my calculator cosine of 72 times 300. What'd you get?
92.7.
Perfect. 92.7? Awesome. Okay, so for my side A, 92.7 centimeters. And that's it. So if they give you the angle, you get to put it in. You get to use sine, cosine, tangent just the way it's written in your calculator. So if they give you the angle, you get to use it regularly. If they don't give you the angle, you have to use the inverse. So far, so awesome. Okay. And then the last part that we'll have kind of on the assignment and then that we're going to practice today is going to be solving a triangle. It'll give you two sides. And what I'd like to find is I want to know all the angles and all the sides. So for this one here, I've got, this triangle. So the first one we'll do together. The second one you guys are going to do on your own. This triangle here, I've got 15 for one side, 21 for the other side. How can I figure out the hypotenuse? Fantastic. A squared plus B squared equals C squared. So I would have 15 squared plus 21 squared equals C squared. So 15 squared plus 21 squared is going to give me 666 squared. Or sorry, 666 equals c squared. And square root both sides. And my last side is going to be 25.8. So c will be 25.8. Okay, I found that one. Now I want to find my angles. If you're using the numbers they gave you, try to stick with the two that aren't in decimals if at all possible. It'll give you a better, more exact answer. So I've got 15 and 21 as my two angles. Which one of these would you like to use? Sine, cosine, or tangent? I'd want to use tangent, I agree. Because they give you these two numbers over here, and none of them are the hypotenuse. And the only one that doesn't use hypotenuse is going to be tangent. So this part doesn't matter which one you want to do. Do you want to solve for A or B? B, love it. So I'm going to solve for angle B. That means that this one over here is going to be the adjacent. This one over here is going to be the opposite. So that gives me tangent of the letter B, which I don't know what it is, equals my opposite over the adjacent, so equals 15 over 21. Because they don't give me the angle, I have to use the inverse. So to solve it, I would push into my calculator the inverse of tangent equals 15 over 21. And I'm left with 35.5. And for those people who are following along on YouTube, I'll write that one for those two ladies. So it would have been tangent to the inverse value, 15 over 21. Okay, so this one I've got was 35.5. The last thing I needed was to figure out angle A. How can I find angle A?
Add C and B and then subtract it from 180.
Fantastic. Add C and B, subtract that from 180. So I should have 5. That's not right. I should have 54.5 for the last one. So I've got that angle, I've got this angle, I've got that side. That's what I'm looking for in that last section. Okay, I want you to do one of them all by yourself. And I'm going to let you know a little trick. If you can do it so the top number of the fraction is the variable, it makes a lot less work. So try to figure this one out. I'm walking around checking to make sure you got.
I got stumble fast. Oh my god. Are you serious? There's $2. Spending money on stumble guys, bro, that's like McChicken, King. What do you mean?
You turn the lights off.
Yep, sorry about that.
Just get that ad. Oh yeah, I never met that. So fast told you, buddy. You're a goofy. You're a goof. What are you doing? Get in the bag. I'm spending money on soul. It's a knockoff version of the console. $850. Really? Yeah. I think it took you longer than this weekend. It's probably 2 weeks. So, this week, and I got my check, I guess. So, he's actually, I can get $850. So now I got a number. I don't know either, bro. LinkedIn with the plug, okay? What? LinkedIn with the plug, alright.
What's that? So this stuff, these ones can only be at the side cosine or tangent. So the angles can't go on the other side of the equal sign.
Entonces lo puedes 24. Luego ya que tenía 24, 70, de 20, y luego va a hacer, entonces
So
Bro, quit fucking spinning, I'm trying to get this game.
if you're gonna do sine, you got the opposite, which is gonna be 20. So it'd be sine of 66.
George.
Sure.
no necesitas sign si no tenías el otro.
Yeah, so if you have 66, it'd be sine of 66, you actually write the 66 here.
Es que sign debe always be same center.
And then equals, erase that stuff there. No. So these parts on the other side of the equal sign are gonna be the others. So it equals the opposite, which is 20. So you know what hypotenuse is?
I don't know, but he's just fat. He's not that fat. He's just big. He's pretty. He's just big.
So this is a variable.
He ain't skinny. He ain't skinny yet. What is he fat?
You can solve for that x by itself. So if this, you go in your calculator, and just adjust it. Then you can solve for that x.
Definitely got some extra. But he's got work.
I got 89%.
Perfect.
He's just pushing me up.
So we're gonna.
Yeah.
Okay.
Birkin bag? That's a female bag. You know that. Birkin bag is for females. Yeah, it's like Birkin bag.
So far, yes.
Why would you get a Birkin bag? You don't want to get a Louis bag. No, I don't want a Birkin bag. You got a Coach bag? I did. You're right. I bought that when I was 15. I'm slow. Dude, I'm 16. Yo. Oh, boy. There's only 2 more races.
Do this.
Look, I am.
What do you have for the answer?
I don't know. You didn't give me enough information.
You got more than enough information up there.
I only got one angle degree and one side.
Alright, I'm gonna give you about 30 more seconds and I'll work this one.
You didn't give me 3 minutes.
20 over x. Fantastic. So first you have this on the bottom. X is at the bottom. You multiply both sides by
Bro, you're not gonna tell me. So
Yep. Of course, if you look at it, so right.
No, I sold. No, sold. I'm leaning off the walkway. I'm leaning off the walkway. I'm sipping at your bed. Yeah, I know. He should. It's just right now. I knew a kid in real life named Kobe Jack. His last name's Gilbert.
All right, I'm gonna work through this one. The parts I'm gonna kind of point out, as a lot of you guys found out that if you divide by the variable, it makes it a little bit trickier. So if you can get your variable on the top, it makes it so it's like one step. So I'm gonna go through and if I'm looking at it and I want my variable to be on the top, I can either have my adjacent on the top, the opposite on the top, or the adjacent on the top, but I don't have a hypotenuse. So I'm going to try to do my tangent. Okay? Either way, it's going to give you the exact same answers. It's just a couple extra steps. So the first thing I did is I just wanted to figure out all the angles that are inside this triangle. So if this is 90, this is 66, that means that this one over here, perfect, is going to be 24 degrees. Okay? So this angle is 24 degrees, this one's 66 degrees. I'm going to try to use it so that way my variable is on the top of my fraction. So I'm going to make this one over here as my variable. So that's going to be my opposite. So that gives me tangent. The opposite of that is going to be 24. So tangent of 24 equals x over my adjacent, which is 20. Okay, again, tangent of the angle is going to equal opposite over the adjacent. X over the 20. I'm going to show you that you can use either way, and that's going to give you the same answer. Tangent of 24. Tangent of 24. That's going to give me, if I were to write the decimals out, it'd be 0.445 equals x over 20. And now I want to get the x all by itself, so I'm going to multiply both sides by 20. So I get 0.445 times 20. It should be x equals 8.9. That means that this length right here is going to be 8.9. The very last step for me to figure out the hypotenuse, I've got a leg, I just don't have the hypotenuse. So I'll have 200 squared plus 8.9 squared, because I'm using Pythagorean's theorem. 20 squared plus 8.9 squared. And that's going to give me that's not right. 20 squared plus 8.9 squared. There we go. That's going to give me 479.21. I got to square root that. So my final answer should end up at 21.9. Okay. If you used a different way, I'm going to use a different pen just to show you that it didn't matter which one we used. Okay, I saw some of you guys were using the sine values, which is fine. You guys were doing sine of 66, which was fine. So I got this angle here. Sine is going to be the opposite over the hypotenuse. So that equaled 20 over my hypotenuse, which I had no idea. I'm going to call it C just because I've already used X. So sine of 66 is 0.914 equals 20 over C. I need to make sure that C is not on the bottom, so I'm going to multiply both sides by C. These ones cancel out. And I'm left with 0.914 C equals 20. Now I need to get C by itself, so I'm going to divide both sides by 914. 0.914. My C value equals 8.9. Again, some death. Whoops. Sorry, not 8.9. Equals 21.9. Okay. At that point, I got the hypotenuse value, and I can solve the other stuff. How you feeling on this stuff? Okay. So what you guys got? Page 603, 8 through 32 by 4s, 35, 36, 37, and 38. The first two, you just have to write the numbers. You don't have to solve for angles. You don't have to do anything else. You just have to tell me sine of A is 1 over 2. Cosine of A is 2 over 1 or whatever it is.